All right, we have been looking at slope of a curve, and we've been using this formula, and the last 2 days we did a whole bunch of examples for the limit h goes to 0, f of a plus h minus f of a all over h. What we want to do today is kind of give another way of thinking about this. We did do one yesterday about the instantaneous velocity, but we want to look at also what's known as the derivative of a function. This is another name that basically means the exact same thing, and you'll see why as we go further. So, what is the derivative of a function at a? You will notice the right side is the exact same formula, right, that we've been doing. What's different is this notation on the left. So it's like f prime, x, f, that little mark represents the derivative of the function at a. Or that little symbol means the slope of the tangent line at a. So no new formulas here. We have the formula with h, and then our alternate formula with the x and the a, but it's basically just a different notation that we write with this f prime of a. And this is known as the derivative of a function at a. So let's look at a couple examples. So we have find f prime of 2, or the derivative of f of x at 2, however we want to say it. So that would be the limit as h goes to 0 of f of 2 plus h minus f of 2 all over h. And I guess technically we also could have used the alternate form, but I like this formula better, especially for this one. So this is 5, 2 plus h plus 1, 5, 2 plus 1, h. So as we look at this, we're going to get 10 over here. This is 10 plus 5h plus 1. So those cancel. So we're left with just 5h over h. H's cancel. So what is f prime of 2? Is just 5. Hopefully that solving that limit, we've done a lot of those, makes sense. Now you can see here, because this is a straight line, the slope of the tangent line, which is all the derivative means, is a different way of saying it, would just be the slope of that line. So we get to there. Now if it's not a straight line, if it's a quadratic, now we'd have to find that. So let's look at finding f prime of 1. So that's the limit as h goes to 0, f of 1 plus h minus f of 1 all over h. This is 1 plus h squared minus 4, 1 plus h plus 1 minus 1 squared minus 4 times 1 plus 1 all over h. And we've done a lot of these, so I'm just going to write this down instead of giving you time to do it here. It's just doing all the algebra. So we get 1 plus 2h plus h squared minus 4 minus 4h plus 1 minus, this is 1 minus 4 plus 1 is minus 2. And you can see here 1, negative 4, and 1 is negative 2. So that cancels. Everything without an h cancels. Everything with an h stays around. h's cancel. And we're left with the limit as h goes to 0 of h minus 2, which is negative 2. So that is what the derivative at 1 is. Okay. Now, let's remember what that means. Okay. So if I go to my calculator, and it's x squared minus 4x plus 1, zoom forward. And I look at the value at 1. So right there is that point. So my derivative at 1, or this is the same thing as the slope of the curve at 1, and you can see if I draw that line, that slope looks to be 2, or it was negative 2, right? Was it what we just got? It was negative 2, right? So that looks about negative 2 because you can see, okay, basically it looks like rise over run looks to be about negative 2. Okay? So when we're looking at the graph, we're kind of just like saying, well, it looks like about that. We're not necessarily finding it exactly. So let me give you an example. So let's say we have this graph, and I'll give you one of these in a second to do. And we picked a point. We said negative 2. So at negative 2, here is negative 2. Right there's the point. What would you guess the slope of the tangent is? So if we draw a little tangent line, I don't know. Is it first as a positive or negative?
Positive.
Positive, and then 4, 3, something like that, right? So this is very like just kind of guessing, right? At negative 1, which is right there. Still negative. Still positive, excuse me. But now it's not nearly as big. That may be only like 1, right?
Yeah.
So we're complete kind of estimation here. At 0, looks like it's negative. Maybe negative 1, negative 2. So like I said, it's obviously negative. Negative 1, negative 2. It's not negative 4. It's not negative a half, somewhere in there. So we're just kind of going around finding the points. Here at 1, it looks like it's positive. Almost looks the same as negative 1, doesn't it? As you see those two lines there. So we'll say that one is 1. At 2, something like that. I would say that almost looks the same as negative 2, right? So we can just go through and try to find what our slope is, okay? So that's the next thing we want to do is we just want to try that on some different values. All right, let's look at our answers here. And once again, not exact answers, not like we're going through. So negative 3. Negative 3 is about here. So it's about there. Positive 1. Sounds good to me, right? So positive 1, 2, so we're in that range. Negative 2. Negative 2 is about right there. Negative, but pretty small, maybe negative a third, negative a half, negative a fourth, somewhere in there. And you can kind of see if it was right at the peak, what would our slope be?
0.
It'd be 0. Negative 1, about here. I'm going to say maybe negative 1.
Yep.
0, I'd say 0.
Yeah.
1, positive,
1.
about 1. 2, that looks pretty close to, where is that? Is it over there maybe? Pretty close to 0. I'll say about 0. 3, right there, that's probably going to be -2. 4 is right there, about the same, -2, -3, somewhere in there. Once again, we're just getting kind of close. General numbers to give us an idea. Positive, negatives, big, small. Second one. So -3, right there. -1/3. -2. -1. -1. Maybe -1/2. I think around 2, the way I think about it is somewhere in there is like the bigger value, right? So it starts like it's at 0, and then it gets smaller negative, it gets bigger negative, and then it starts to get smaller negative again. Because as it gets close to 0, it gets close to 0 again. At 0, maybe going up a little bit. 1/4, 0, roughly, okay? 1, right there in the middle is maybe 1, 2, pretty similar. 3, maybe getting a little bit bigger. 4, maybe a little bit bigger. We're just kind of looking at general. So does that kind of make sense? What this is not an exact science. We're trying to get like big picture idea. I compare this to kind of like when we looked at in pre-calc like parent functions. You know the basic shape of a quadratic and a cubic. We're not worried about exact answers. Here we're looking at the basic value. Is it positive? Is it negative? Is it bigger than 1? Is it less than 1? Those are kind of the distinguishing things. One more thing I want to look at. It's on your homework, but not on the notes, is this. So on the back of the paper there or somewhere on the side, you can write this down. So find the equation of a tangent line at 3 given these two things. Okay. So this is given this information, can we find the equation of a tangent line? Now, we know generally this is our equation of our line. So from the function, f of 3 is 5, that gives us the point, right? That this is 3, 5. The derivative at 3 is a slope of our tangent line. That's the slope of our curve. That derivative, this would represent our slope is -2. So now to find the tangent of a line, we have a point, we have a slope, so we can write down our tangent line like that. So we don't even know what the function is, they just give us that. So this is just about how we understand how to use the point and use the slope to find the tangent, okay? All right, last part of 2.7, we're gonna stop there and you can do the second homework worksheet.